right, so there's two different ways that we can do this. One way, and I just want you to watch and not write, and then I'll give you a chance to write, is to line them up vertically, meaning one on top of the other, and then we will add them together. So it's going to create vertical addition. So when I do that, I'm going to rewrite, so here's my first polynomial, I'm going to rewrite it so that it's in order. So when I see 2x squared, negative 3x cubed, I'm going to write the negative 3x cubed first. And then, and again, don't write, wait till I'm done. And then 2x squared, and then x. That's what standard form means. So I have the largest exponent to the smallest, 3, 2, 1. So that's my first polynomial, and I'm going to add to that my second polynomial. And I'll line up like terms. So negative 4x cubed, I'm going to write underneath my other x cubed term. And negative 6x, do you think it makes sense for me to write that under x squared? Is that a like term? Or should I write it under x? X, yeah, I'll write negative 6x with x plus 3. So then it's creating columns of like terms. So I have my x cubed, so this is all we're doing, combining like terms. I have negative 3, I have negative 4, I have negative 7, x cubed. And then positive 2x squared, nothing to combine it with. And then for my x's, I have 1x, and I take away 6x, I have negative 5x, and then nothing to combine with the 3. That's my final answer. Again, in standard form, 3, 2, 1, nothing, largest exponent to smallest. Setting it up so that my like terms are on top of each other and so that it's in standard form. I'll give you a chance to write and then we'll do another one. So again, the other one is really similar. I'm going to take I'm adding 3 terms together now. So my first polynomial, my largest exponent is 5x cubed. So I'm going to write that first. My next largest exponent within this parenthesis is what? What should I write next if I'm reordering it? Plus 2x squared, because I want to go in order. Then subtract x plus 7. That way it's in standard form, largest to smallest. And I'm going to add to that this second polynomial. So I have 3x squared. Notice that I write it underneath my other x squared term. And then what would come next is negative 4x plus 7. And then my third polynomial is 4x squared, lining that up with my other x squared terms. Negative 8, I'm going to line up with my constants. And then look at this, negative x cubed, I can just go back out front and write that with my x cubed term. Okay, so I've created columns of like terms. And again, I don't typically add this way. I'll show you how I typically do this on the next 2 problems. I think this takes a little while, but it's organized, and it may help some of you. So now I've lined up all of my like terms, and it's just addition. I'm just adding. So 5 plus negative 1, or 5 minus 1, gives me how many x cubes? 4x cubed. and then these are all positive, so I'm just adding up. 2 plus 3 gives me 5, plus 4 gives me, and then for my x's, -1 and -4 give me -5x. And then 7 plus 7 gives me 14, minus 8 gives me 6. And you can use your calculator to add the coefficients here, like just don't put in the x squared. You could do 2 plus 3 plus 4 in your calculator, and it would give you the coefficient that should be right here. Okay, so we'll give you a chance to catch up, and then we'll talk about a different way that we could add polynomials together in the way that I would typically do it. So another way that we can do this is horizontal format. So horizontal means I'm just going to go left to right. So just watch, and I'll give you a chance to write because you haven't seen it before. So looking at C, again, I want to write it in standard form, which means largest exponent to smallest. So I'm just going to look at every term. I don't even care where the parentheses are. And I'm going to pull out my largest exponent. The largest exponent I see here is x squared. So I have 2x squared and 1x squared. So I'm just going to add them together. I have 2 here, 1 here. I have 3x squared. My next largest exponent I'm going to do in a different color. Maybe I'll box it instead. I have 1x and 1x. So I have 2x. And then I can combine these like terms. -5 plus 6 gives me +1. There's my answer. So I'm just really looking and matching up like terms and adding them together. I don't have to set them up. What? Can you use colored pencils? You can. They're up here. Let's take a second and write. So same thing on D. Let's start with you telling me what the largest exponent is here. Look at all of them. What's my largest exponent? 4. I have x to the 4th positive. So notice I take the sign and whatever coefficient. Now this is just 1, but I take all of it. And then 10x to the 4th. So I have 1x to the 4th, 10x to the 4th. So how many do I have altogether? X to the 4th. And then I say, okay, so that's x to the 4th. Do I have any x cubed terms? And I do. I have -5x cubed. Do I have any other x cubed terms? No. So I can just add that to my answer. Do I have any x squared terms? No. Do I have any x terms? Yeah, I see +3x and -6x. So if I have 3 minus 6, what do I have? And then I have some constant terms. I have -2, -8, so I have -10. Okay, do you see how this should be the easiest unit so far? Like, we're just adding. Yes, there's like a lot to keep organized. You have to be organized as you work through it. We're just adding. And then we're going to talk about multiplying. It's not going to be much more challenging. The hardest part, honestly, is what we skipped, which is the vocab, which we'll do tomorrow. Okay. subtract polynomials. I want you to cross this out. That's silly. Okay, and when I say subtract polynomials, I mean don't ever subtract polynomials. I mean always change it to addition. Never subtract them just as they are. So how do I change it to addition? Well, I'm going to take my negative that's between them and I'm going to distribute it to every term that's being subtracted. This is the term that's being subtracted. And if I do that, I can change it to addition and just change all of my signs. So really I'm adding negative 2x cubed, negative 4x squared, positive 3x, negative 1. So all I'm doing is distributing the negative, changing it to an addition problem. So if it's an addition problem, we can do exactly what we just did. So I don't even need to look at that term up above anymore. This is now my new problem. I'm adding this term to that term. So exactly what we just did. What is the largest exponent value? X cubed. So I have 6x cubed and negative 2x cubed, and now I'm just adding. So if I have 6 plus negative 2, how many do I have? 6 subtract 2.
This is worse than your
6 subtract
4.
2. Thanks, CJ. Is 4x cubed. Whew. Then I go through and I find if I have any of the next smallest exponent would be x squared. None here. Oh, look, right here. Negative 4x squared. And then I say, do I have any just x terms? Well, 5x, 3x. How many x's do I have all together? 5 plus 3 is...
8.
Thanks. 8x. And then I have negative 3 and negative 1. And if I combine those, I have negative 4. And there's my answer.
Great. How'd you get that?
Let's do another one. And then I'm going to let you try these on your own. Again, never subtract. Who in here is going to do this? Keegan's going to do this. Keegan's going to be like, I've got this. I don't need to rewrite it. I'm just going to do it as a subtraction problem. And Keegan's going to get the last 2 terms wrong. Okay? Because that's what happens is you're like, okay, I know I'm distributing this, but I'm not rewriting it. And then you get to like this number and you just forget to change that to negative 10 and you write positive 10 and I take points off.
Thanks for telling me that I'm going to do that.
Yeah,
So
don't
I'm
do
gonna
it.
try now because I can't get it right.
You won't get it right. You won't get it right, yeah. So never subtract. Instead, distribute our negative to every term that's being subtracted and change it to an addition problem. Plus, and now in my parentheses, I'm just going to change all of the signs. Becomes positive 12x to the 4th, negative 3x cubed, positive x squared, negative 10. And now I'm adding. I don't even need to look up above here because I've rewritten my problem. What's my largest exponent? X to the 4th. I have 16x to the 4th and 12x to the 4th. Again, you can use a calculator and do 16 plus 12. But what is that going to give me? 28. X to the 4th. And sometimes it's nice to like, okay, so I've done the x to the 4th. You can cancel them out. I've combined my x to the 4th terms just so you're not looking at as much. So then I look to see what comes next. What would come next?
3.
x cubed. So I look and I see, okay, here's an x cubed term. Do I have any here?
No.
No. So I just have negative 3x cubed. And again, you can cancel that out because I've done that set of like terms. So then we look for x squared. So I see negative 2x squared and 1x squared. So what do I have all together? Negative 1x squared, and you don't need the 1. And then I look to see so I can cancel those out too. So then what's left? Well, I have negative 2x, right? That's just all by itself. I can cancel that out, and then this is all that's left, 31 minus 10, which gives me 21. And that's my answer. I can't combine anything because none of these are like terms. They all have different exponent values. Please try just the next two subtraction problems, and you can set them up like one on top of the other like we started with. I just typically tend to just kind of combine things as I see them. So you try just C and D, then we'll check our work before we move on and do some more classwork.